All right, this is another little walkthrough of this AWA 6AQ5 transmitter. I decided to go do a little bit more to it, which is I wanted to be able to switch bands with the previous setup. I was just going to be fixed at 40 meters. So I designed in 3D print some coil forms. So this one I made for 80 meters. And then this one is for 40. And the one in the unit right now is for 20 meters. I'm using 20 gauge, just enamel copper wire. I believe the 20 is running 6.5 turns. The 40 is around, what was it? It's like 16.5. And then the 80 is right at 30.5 turns. Power output on 40 and 80 is about the same. It's about 8 watts. And then 20, I probably have more tweaking to do, but I wasn't expecting a whole lot on 20. But I am getting it decent. There's no chirp. So it's sounding pretty good. It's not like a huge amount of output. When I get a little bit more adjustability of the loading side of my Pi network, I can probably get a little bit more out of it. But I also added a nice ammeter. I was just digging through my stuff and I found a 100 milliamp DC ammeter, which is pretty nice. And yeah, so here, this is on 20 meters. Let me swap my coils out real quick and I will show you this on 40. Okay, I just swapped coils and I swapped the crystals. So I'm running a 7050 kilocycle, so 7.05 megahertz, right in the middle of the Straight Key Century Club watering hole. Okay, so the tune-up procedure on these things basically is as follows. I'm going to fully enmesh both sides, you know, the plate and the loading. Notice that. Let's reduce the capacity. We should see a dip right around there, and you see the dip already is at about 7.85, and then now we would tweak this until we get a little bit, there we go, should be right about 7.9 to 8. I can mess with this even more. Some of the issue I run into is with, because I don't have any, like a shield or anything, so the capacitance of my hand interferes a bit, but sounding really good. Efficiency is actually pretty darn good. And then another nice thing is by keeping the loading side, when I switch over to my external antenna, I can adjust the loading so that I'm most efficient and I have the best power transfer there. So let's try this on 80 meters. Okay, well, let's do a tune-up on 80. So I've fully enmeshed my load side. Let's do the same with my plate side. And then I'm going to engage this real quick, and then let's quickly try to get this right. It's pretty close. And I can continue to mess with it a little bit more. And normally you just kind of go back and forth, but efficiency is quite good. So we're getting right now about 7.4 watts out. I can, if I let this warm up longer, I can get closer to 8, and especially if I start fiddling around with this. But sounding good. It's not, you know, the efficiency is pretty good. And yeah, so there you go, 20, 40, 80 meters. This is working well. The output on 40 and 80 is closer to 8 watts, and then on 20 meters it was around 3. I can probably get that up to maybe 4, but still happy with it. It's still quite useful. So now that this is all working really well, the next step is design a fully integrated housing that will hold my nice little ammeter. It's going to have the knobs right up front and a shield of sorts. And so what you should see is it'll look more like a traditional transmitter you probably would have seen in the 60s, kind of like a Heathkit AT1 sort of style. So anyways, that is that. And yeah, these little coil forms are working out pretty good. The little octal socket in the bottom. Pretty happy with it. There we go.